Dear students, in the class we are going to discuss the problems in multiple integral. First problem, you can choose from different. Okay, this is print already. Right here. Can view the rulers, those are easy to write. Okay, first we write the problem. Example 1. Evaluate double integral over the region R xy dx dy, where R is the region R is the region bounded by the line x plus 2y equal to 2 lying in the first quadrant. Once again I read the problem. Evaluate double integral over the region R xy dx dy, where R is the region bounded by the line x plus 2y equal to 2 lying in the first quadrant. So for this, first we have to draw the rough sketch. You can take this. Yeah, blue pen. You can write the solution for this. Okay. So we draw a rough sketch of the boundary of R, and we have to identify the region R. So how to draw this? Here given that straight line x plus 2y equal to 2. So this x plus 2y equal to 2 can be written as x by 2 plus 2y by 2 equal to 1. So this can be written as x by 2 here, the 2 get cancelled, plus y by 1 equal to 1. So what is this? This is a intercept form of the straight line, where x-intercept is 2, y-intercept is 1. So we can draw a rough sketch based on this. Can we draw first? We can draw its y-axis, x-axis. So intercept form is there, x by 2, y by 1 equal to 1. In case it is 1, put this 2 here. Equally we can take here 1. So we can draw a straight line for this. We can choose the straight line here. Straight line, okay, fine. So start from here and then end with here. Okay. So We take that 1 is here. So this is origin 0 comma 0. We can take this as point A. The point A is 2 comma 0. That means y-axis is 0. And then here we can take this as point B. Point B is 0 comma 1. Then what is the region of integration? This is the region of integration. So the region of integration covers that x equal to the straight line x equal to 0, and then y equal to 0, and then the straight line x plus 2y equal to 2. So which is lying in the first quadrant. Therefore we can write here what are the boundaries. The boundaries of integration, or the boundaries of region R, are the lines. What are the lines? X equal to 0, y equal to 0, and the straight line x by 2 plus y by 1 equal to 1. Okay, fine. Now from this, so here the limits are that variables of integration are not given here. See in the problem, here the limits are not mentioned in the integration. Therefore arbitrarily we can take, first we have to integrate with respect to x, afterwards we can integrate with respect to y. Therefore generally we can write that I equal to double integral over the region of xy dx dy. What is the inner integration here? X is the inner integration variable. Therefore we can draw a parallel line to x-axis, and draw the parallel line to x-axis. In case we are taking this as straight line PQ, which is in the region. So when we perform the inner integration with respect to x, we have to treat y as a constant temporarily, and first we have to fix the limits for x, then we can fix the limits for y. So geometrically, if you are taking the treating y as a constant, it is equivalent to draw a parallel line to x-axis arbitrarily. First you have to draw the parallel line to x-axis arbitrarily. So when we are finding that limits for x, first see that point P here. We start from the straight line x equal to 0, because we are going to find that the limits of x. So it is start from x equal to 0, x equal to 0, and end with the straight line. Already it has given x plus 2y equal to 2, is it not? That can be written as x equal to 2 minus 2y. So x equal to 0 and x equal to 2 minus 2y are the limits for x, is it not? So what is the next step? Next step we are going to find that limits of y. Okay, therefore we can write that I equal to double integral, it is outer integration, inner integration xy dx dy is there, then it is the inner integration, this is the outer integration. First we have to limit for x equal to 0 to x equal to 2 minus 2y. Always we have to keep it in mind, inner integration may be that constant or function of y alone, it should not contain any x. Okay, so next is we have to write the limits for y. So you can see here, you draw the parallel line to y. So y, where is y, always should be constant. Okay, so in the region we can see that y start from 0 always and end with that y equal to 1. So how to find that intersection point of this here? If you finding that intersection point of this point may be written as c. What is c point? 1 2 comma 1. Okay, so here see that y varies from 0. I can mention here y varies from 0 and y varies from 1. Anywhere you can see in the region y varies from 0 to 1. So therefore we can write that 0 less than or equal to y less than or equal to 1. That means you can write that here y equal to 0 to y equal to 1. From the given problem, here you can see that the limits are not mentioned here. When the only region is given here, from the given equation x plus 2y equal to 2, and then lying in the first quadrant also is given. So from this concepts or from this hint, we have to find that region for this integration. Okay, so first we have to fix the order of the integration. Arbitrarily we can fix that x is inner integration, y is outer integration. Okay, but the order of integration is also chosen, is based on the problem, is based on the problem. Okay, sometimes even we can choose that y as a inner integration, x as a outer integration. At the time, first we have to integrate y, temporarily keep it that x as a constant. Secondly, you can integrate x. Okay, so in the problem we are taking that x is inner integration, x is inner integration, y with respect to y is outer integration. Now we have to find the solution for this. That means integrate. First we have to integrate with respect to x. So therefore we can write that 0 to 1, and then if we are integrate with respect to x, keep it y as a constant, and then integration of x is what? X square by 2, using the formula integration over x power n dx equal to x power n plus 1 divided by n plus 1 plus c. Using this formula, it's the formula of the integration. So using this formula, we can integrate here y x square by 2. What are the limits here? Already it is given, x equal to 0 to x equal to 2 minus 2y dy. In the next step, we can write that integral over 0 to 1, and then 2 is constant. Now we can write that y by 2, and then substituting the limits. Upper limit is what? 2 minus 2y whole square minus substituting 0 here, 0 dy. So that means it's 0 to 1 y by 2. If you are taking 2 outside, then 2 square is there, that means 4, 1 minus y square dy. Simply we can cancel the 2 here, 2 we can keep it here, taking the 2 outside, integral over 0 to 1, writing y here, expand 1 minus y whole square. That means 1 plus y square minus 2y dy. Substituting, that means multiply the 2 here, sorry, substituting that y inside, y plus y cube minus 2y square dy. If you are solving this, you will get that 2 integral over 0 to 2. That means we are now we are integrating with respect to y now. So y square by 2 plus y power 4 by 4 minus 2 y cube by 3. If you are substituting, or if you are substituting that lower limit here, you will get the 0. Okay, fine. So 2 here, and then for that it's 12 here. So how many times? 6 times plus 3 times minus 4 times 8. So that will cancel 6. 6 plus 3, 9 minus 8, 1. 1 by 6 is the answer for this. So what is the answer here? You can write. Okay. Okay. That means answer is double integral over R. What is the question? Double integral over R xy dx dy. What is the region here? X plus 2y equal to 2 and in the first quadrant. Under the first quadrant. Is it not? So what is the answer for this? 1 by 6. It's clear? Okay. For the same problem, we can change the order of the integration at the time. How can you get the answer for this? Simple. Write the integration I double integral xy. First we have to integrate dy, keeping x as a constant temporarily, and then you have to integrate respect to x. So now what happened is, see the figure here. Now we can draw the parallel line to, in case we are draw the parallel line to y. See this. It is start from y equal to 0. We start from y equal to 0 and end with the straight line x plus 2y equal to 2. So therefore, we are solving for y. What happened is y equal to 0, and then second line is x plus 2y equal to 2. Is it right? So we have to write in terms of y. Therefore, 2y equal to 2 minus x, y equal to 1 by 2 into 2 minus x. So what are the limits of y? Y equal to 0 to y equal to 2 minus x by 2. 2 minus x by 2. Similarly, what is limits for x here? We can take the limits for x. So in case if you are choosing limits for x, what happens? So x equal to 0 to x equal to 2. So this is the limits for x. So you can write that limits for x here. x equal to 0 to x equal to 2. Therefore, if you are integrating this, first you have to integrate with respect to y. You can get integral over 0 to 2, keeping x as a constant. Integrate y square by 2, vary from 0 to 2 minus x by 2. Here dx we can write. So that is equal to integral over 0 to 2. We can take that by 2 outside. 1 by 2 integral over 0 to 2. If it x here, 2 minus x by 2 whole square dx. So already 2 is there. If we are squaring the denominator 2, then we will get that 1 by 8 integral over 0 to 2 x into 4 plus x square minus 4x dx. We have to multiply that x inside 0 to 2, 4x plus 4x square minus 4x cube. Sorry, okay. No, it's not correct. We have to change it. We are multiplying x, is it not? So therefore, plus x cube minus 4 x square dx. We have to integrate with respect to x now. 1 by 8 4x square by 2 plus x power 4 by 4 minus 4x cube by 3 from 0 to 2. Okay, so 1 by 8, 4 into 4, 16, 16 by 2 plus once again 16 by 4 minus 4 into 8, 32 by 3. If you are solving this, once again you will get that 1 by 6. Okay, so it is not the matter whatever the order is taking for any problem. Order is taking for any problem. First you have to integrate with respect to x or integrate with respect to y. It is based on the problem. In case if we are taking if we are taking first integrate with respect to x, in case the limits are in squares, that is not the difficult to integrate. In case if it is taking inner integration, limits are in root, limits are in root, at the time you can change the order of the integration. At the time the root may be vanished. Okay, so that taking the order of integration is your choice. Okay, and based on the problem. Thank you. We can move for the next problem. Example number 2. Example number 2. Evaluate double integral over r e power minus y by y dx dy by choosing the order of integration suitably. By choosing the order of integration suitably. So how can we choose that order of integration chosen suitably? You can see the solution here. Write the solution for this. No, the problem is not completed now, but because we need to write that limits also. Is it not? So from here suitably, given that, come on, given that without limit how can we solve this? Given that the region R is the region bounded by the lines bounded by the lines x equal to 0, x equal to y, and y equal to infinity. Okay. For any problem, first we have to draw the rough sketch for this. So can we draw the rough sketch? First we can take the axis here, x-axis, y-axis. So in the corner we can draw the x-axis and the y-axis. Simply. Okay. Now we can choose the points. This x-axis we know, this y-axis we know. So what are the boundaries here? Region bounded by the lines x equal to 0. X equal to 0 means y-axis, x equal to 0, x equal to y. X equal to y is the straight line in the 45 degree. Okay, so you can take that straight line here, 45 degree. You can draw the straight line in the 45 degree. Okay, good. Next one is we have to select the region. Is it at x equal to 0, x equal to y, and y equal to infinity? Y equal to infinity means, I don't know, this may be somewhere y equal to infinity. This y equal to 0. So this point is the origin 0 comma 0. This is the point x comma infinity. How can we choose that the suitable order of the integration? Because in the problem also they are not mentioned any order of the integration. Just they are giving the region. From the region we can choose the order of integration. So how can we choose that? In case 1, we can write case 1. In case we wish to integrate with respect to y first. Y integrate first. That means integrate first with respect to y. We can write like that. Okay, integrate first with respect to y. With respect to y. At the time, keep it that x as a constant. X is the constant here. Then how can we write that double integral I? That means integral over double integral over e power minus y by y dy dx, because we are integrating first with respect to y, is it not? So therefore we have to write that limits of y here, y equal to y equal to, then only we have to write that limits of x here, is it not? So in, if you are integrated with respect to y means first you have to draw that parallel line to y axis, parallel line to y axis. So y equal to x to y equal to infinity, is it not? The region, you can see in the region, we are taking straight line parallel to straight line, y equal to x to y equal to infinity, is it not? In case if you are taking, so what is the limits of x here? X equal to 0 to x equal to infinity, because y equal to x na, x equal to 0 to x equal to infinity. Then we can see that here the choice of integration is wrong, because in case if we are integrated with respect to y means we have to use that the integration by parts, but it is in that y power minus 1, is it not? So both of them are, it is exponential and it is the inverse, so it is somewhat difficult to integrate. Therefore we have to change that order of the integration. So here we can note that the choice of integration is wrong. In case we are not able to integrate it properly, okay, so therefore we have to change the order. We change the order of integration. That means integrate with respect to x first, e power minus y by y, integrate with respect to x first, then you integrate with respect to y. At the time you have to write that, you have to draw the parallel line to x axis. So now we can omit this line here. We have to draw the parallel line to x axis, is it not? So in case if you draw the parallel line to x axis, what happened is x equal to 0, start from x equal to 0 and end with that x equal to y, is it not? So therefore we can write here x equal to 0 to x equal to y, y varies from 0 to infinity. Okay, now we can integrate. We can see that how to integrate that solution. Write the solution for this. First we have to integrate with respect to x. That means e power minus y by y, keep it as a constant. If you are integrated with respect to x, then it is x 0 to y integral over 0 to infinity dy. Therefore integral over 0 to infinity e power minus y by y into y dy. That y get cancelled. Now it is very easy to integrate. That means e power minus y by minus 1 from 0 to infinity. Therefore take it that minus outside, e power minus infinity minus e power 0. E power minus infinity is 0, e power 0 is 1. Okay, this is very important point. So therefore minus of 0 minus 1, that means the value is 1. So from this problem easily we can say that that is the order of integration is depends on the problem or function to be integrated. Okay, thank you. In the next class we will see some more problem based on this region of integration. Thank you.